James Webb Space Telescope, discoveries that shatter reality. Suspended in the void, 1 million miles from Earth, humanity's most advanced eye is witnessing phenomena that demolish everything we thought was true. The James Webb Space Telescope has pierced the cosmic veil, reaching farther into the darkness than any device before. What it has uncovered isn't just surprising, it's fundamentally incompatible with our understanding of physics. Primordial galaxies that violate the laws of time, wandering singularities that predate creation, and evidence suggesting our universe might be imprisoned inside something far larger. If you're fascinated by cosmic mysteries that rewrite reality, subscribe now, because these revelations will permanently transform your perception of existence. Let's dive in. The cosmic expansion paradox. The universe has a problem. A mathematical catastrophe so severe that it threatens to topple the entire foundation of modern cosmology. For generations, scientists operated under the assumption that cosmic expansion followed predictable uniform patterns across all of space. The Hubble Space Telescope provided measurements. Theoretical physics provided predictions. Everything aligned into a coherent picture of how our universe grows. Then James Webb penetrated deeper into cosmic history than anyone thought possible. And that coherent picture shattered into irreconcilable fragments. The cosmos is stretching at wildly different rates, depending on which method you use to measure it. Imagine a sphere expanding outward. Logic dictates it should grow uniformly in all directions, but observations suggest parts of this sphere are inflating at radically different speeds than others. This violates fundamental physical principles. The laws governing space-time demand consistent expansion across the entire cosmic fabric. Webb has validated astronomers' worst fears. When researchers calculated expansion using distant stellar beacons called Cepheid variables, they arrived at one specific value. When they computed the same rate using the ancient light of the cosmic microwave background, they got an entirely different answer. This discrepancy isn't trivial or explainable through measurement uncertainty. We're confronting a gulf so enormous that it implies our basic comprehension of reality contains fatal flaws. The scientific community calls this catastrophe the Hubble tension. That terminology severely understates what we're actually facing. This isn't a simple calibration issue or instrument error. After analysing more than 1,000 Cepheid stars distributed across 5 separate galactic systems, spanning 130 million light-years of space, the contradiction persists. Statistical analysis confirms these measurements are accurate. The consequences are staggering beyond measure. Either our theoretical models of universal mechanics are catastrophically incomplete, or some unidentified phenomenon is literally tearing the fabric of existence apart. Dark energy, that enigmatic force propelling cosmic expansion, might operate through mechanisms we've never conceived. Certain spatial regions could be expanding dramatically faster than others, generating rifts in space-time that obliterate everything we assumed about cosmic structure. Adam Ress, the Nobel laureate whose research exposed this crisis, stated it clearly. With measurement uncertainties eliminated, what remains is the genuine and thrilling prospect that we've fundamentally misunderstood the universe. The word thrilling seems inappropriate when you grasp the implications. If our foundational understanding of how space expands is wrong, then every calculation we've made about the universe's age, dimensions, and eventual destiny becomes questionable. Webb's unprecedented measurement precision has eliminated all doubt about the data quality. Both Webb and Hubble independently detect the same impossible contradiction. The universe is expanding, but through a process that violates physical laws as we comprehend them. This revelation alone would be sufficient to invalidate cosmology textbooks worldwide. But Webb had only begun its assault on conventional science. As the telescope continued surveying the deepest reaches of space, it began identifying structures that cannot exist, phenomena that resist explanation, and patterns suggesting our reality is far more hostile and alien than we dared imagine. The expansion paradox was merely the opening salvo in a series of discoveries that would compel scientists to abandon everything they believed they understood about the cosmos. Galactic titans in the cosmic Dawn 6, colossal aberrations drift through the primordial universe, and they're demolishing the established timeline of galactic evolution. When James Webb aimed its infrared sensors at what appeared to be vacant cosmic territory near the Big Dipper constellation, Astronomers anticipated finding primitive proto-galaxies fumbling through their earliest developmental phases. What they discovered instead were 6 fully mature galactic behemoths that shouldn't have possessed sufficient time to reach such enormous proportions. These cosmic giants harbour stellar populations nearly matching our Milky Way's total count, yet they assembled when the universe had completed merely 3% of its current lifespan. Consider attempting to cultivate a fully grown sequoia tree in 90 days. That's essentially the temporal compression these galaxies achieved on a cosmic timeline. Star formation is a gradual process. Gravity requires millions of years to accumulate, sufficient material to ignite thermonuclear fusion. Yet these 6 systems somehow accelerated their development, transforming into galactic leviathans while the cosmos remained in its infancy. The discovery occurred almost serendipitously. Astrophysicist Erica Nelson was scrutinizing thumbnail-sized segments of Webb's deep field imagery when several crimson dots caught her attention with their impossible brilliance. Reddened light typically indicates ancient photons stretched by universal expansion during their lengthy voyage toward Earth. These objects exhibited both extreme age and staggering luminosity, a pairing that defied rational explanation. Each massive galaxy contains between 10 billion and 100 billion individual stars. Reaching such tremendous sizes so rapidly would have demanded the formation of hundreds of new stars annually for hundreds of millions of consecutive years. Our Milky Way, in contrast, generates approximately 2 stellar births each year. These ancient systems operated as stellar foundries running at production capacities that contemporary physics declares impossible. The research team has unofficially designated these structures universe breakers because their existence threatens to shatter our comprehension of cosmic structure formation. According to every simulation and theoretical model scientists have constructed, matter in the nascent universe should have coalesced slowly and systematically. Smaller formations would gradually merge into larger assemblies across billions of years. These 6 galaxies obliterate that entire chronology. They demonstrate that the early universe possessed organizational capabilities and structural complexity that cosmologists never predicted. Either there exists a completely unknown mechanism enabling rapid galaxy assembly, or our fundamental assumptions about cosmic development are catastrophically flawed. The discovery raises terrifying questions about dark matter's function during early, cosmic epochs. If galaxies could achieve such massive scales so quickly, dark matter must have been clumping together and attracting ordinary matter at velocities far exceeding current theoretical predictions. The invisible framework shaping our universe might be far more aggressive and unpredictable than we comprehended. Joel Leger, among the astronomers investigating these structures, perfectly captured the magnitude of this crisis. We examined the extremely early universe for the first time and uncovered something so unexpected that it generates authentic problems for science. Confirming whether these truly represent standard galaxies will require additional spectroscopic observations with Webb's instruments. What those subsequent studies unveiled would prove even more disturbing than anyone anticipated: the naked singularity. A cosmic monster containing the mass of 50 million suns drifts through the void completely isolated, and it's rewriting the history of the universe. Deep within the early cosmos, James Webb identified something that contradicts every theory of black hole genesis. UHZ-1 is a supermassive black hole with virtually no surrounding galaxy. It exists essentially exposed, wandering through space without the characteristic swarm of billions of stars that typically accompany such massive entities. Most supermassive black holes anchor themselves at galactic centers like cosmic keystones, encircled by rotating disks of stars, gas, and particulate matter. They maintain symbiotic relationships with their galactic hosts, expanding together across billions of years through an intricate gravitational ballet. UHZ-1 violates all established patterns. This cosmic nomad compresses enough mass to equal 50 million solar masses into a region smaller than our planetary system. 2. Contextualize that density. If Earth were reduced to marble size, UHZ-1 would remain invisible to human vision, while containing more matter than hundreds of billions of ordinary stars. What renders this discovery genuinely disturbing is the temporal context. UHZ-1 exists during the universe's childhood, merely 600 million years after the Big Bang. Conventional black hole formation demands the death of massive stars, requiring time for the primordial stellar generation to form exhaust their fuel, and detonate in spectacular supernovae. That sequence should consume far longer than 600 million years. Roberto Maiolino, the Cambridge astrophysicist who helped identify UHZ1, characterized the finding as completely beyond expectations. The object challenges every theoretical model scientists have developed for supermassive black hole growth and development in the nascent universe. 3 competing theories attempt to rationalize UHZ1's existence, and each possibility grows, progressively more unsettling. The first hypothesis suggests certain black holes form directly through the gravitational collapse of enormous gas clouds, completely bypassing stellar intermediary phases. The second proposes that intermediate mass black holes somehow expanded at physically impossible rates by consuming matter faster than radiation pressure should permit. The third theory presents the most disturbing scenario of all. UHZ1 might represent a primordial black hole created during the universe's opening seconds amid violent density fluctuations occurring immediately after the Big Bang. If accurate, this means UHZ1 has been lurking in cosmic darkness since the absolute beginning, waiting 13 billion years for stars and galaxies to emerge and illuminate its presence. UHZ1 represents merely one specimen among hundreds of similar objects Webb has catalogued. These compact red sources appear throughout the early universe, each one potentially a cosmic monster defying explanation. They radiate with the luminescence of matter being shredded and superheated as it spirals toward their gravitational abysses. The existence of these isolated black holes suggests the early universe was far more chaotic and violent than cosmologists ever envisioned. Rather than the gradual, orderly assembly of cosmic architecture, we might be witnessing evidence of primordial catastrophes that forged massive black holes before the first stars ignited. If UHZ1 truly is a primordial black hole, it represents something far more ancient and alien than any galaxy or star system. But UHZ1 wasn't the only impossible singularity Webb would uncover, hiding in the cosmic depths. Black holes before stars, singularities older than the first stellar ignitions, are illuminating the universe, and they might have existed since the instant of creation. Scientists have traditionally assumed supermassive black holes formed after the primordial generation of massive stars collapsed in spectacular terminal events. This process should require hundreds of millions of years as gravity slowly aggregates sufficient material to trigger nuclear fusion. Stars live their brief but luminous existences and then explode in supernovae, leaving behind stellar remnants. James Webb has uncovered evidence of supermassive black holes existing when the universe had aged barely 400 million years, far too early for conventional formation mechanisms to function. Andrea Ferrara and his research team at the Scuola Normale Superiore in Pisa, Italy, propose a radical resolution to this cosmic enigma. What if black holes, not stars, served as the universe's first significant sources of illumination? What if primordial black holes formed during the chaotic opening seconds after the Big Bang were already present in the darkness when the cosmos remained in its infancy? These hypothetical primordial black holes would have originated through completely different mechanisms than stellar black holes. Instead of collapsed stars, they emerge from extreme density variations in the primordial plasma, existing less than 5 seconds after the Big Bang. Visualize the nascent universe as a violently churning cauldron of energy and matter, with certain regions becoming so compressed that they collapse directly into black holes without ever generating stars. The evidence Webb has accumulated supports this extraordinary scenario. Numerous bright sources in the early universe appear point-like rather than extended, suggesting they're powered by compact objects rather than distributed stellar populations. When material approaches a black hole, it heats to scorching temperatures and emits brilliant radiation. From cosmic distances, this superheated matter can appear nearly indistinguishable from starlight. If this theory proves correct, primordial black holes were consuming the universe's first gas clouds, growing progressively more massive while simultaneously illuminating the cosmos. These monsters would have been suspended in darkness for hundreds of millions of years, essentially waiting for the universe to evolve sufficiently to provide sustenance. The implications are staggering. Primordial black holes could explain how supermassive singularities grew so enormous so rapidly in the early universe. They possessed a head start of hundreds of millions of years, enabling them to reach tremendous sizes before the first galaxies even began coalescing around them. This scenario raises even more disturbing questions. If primordial black holes were commonplace in the early universe, they might still persist today, invisible and undetected. Some could be wandering through our own galaxy, ancient relics from the universe's violent genesis that predate every visible star. These primordial monsters represent a fundamental paradigm shift in our understanding of cosmic evolution. Instead of a universe that gradually constructed complexity from simple origins, we might inhabit a cosmos born with powerful, massive objects already embedded in its structure. Detecting primordial black holes would also provide crucial insights into Big Bang physics itself, revealing conditions during the universe's opening moments that remain barely comprehensible. But Webb's surveys of these ancient singularities revealed an even stranger phenomenon that challenges our grasp of gravity itself: the infinity collision. Two galaxies are colliding in a cosmic catastrophe that's generating physics we've never witnessed before. When astronomers first observed the structure they nicknamed the Infinity Galaxy, its configuration immediately captured their attention. This cosmic anomaly displays two compact red cores, each surrounded by luminous rings, forming a perfect figure-eight pattern resembling the mathematical symbol for infinity. The galaxy's unusual morphology was merely the beginning of its mysteries. The Infinity Galaxy formed when two massive disk galaxies collided head-on in a cosmic impact that initiated millions of years ago. Galactic collisions aren't uncommon throughout the universe, but this particular collision has generated something unprecedented. Instead of the typical chaotic merger that obliterates both original structures, these two galaxies have preserved their individual identities while creating something entirely novel. What renders this collision genuinely bizarre is the supermassive black hole's position. In standard galaxy mergers, the central black holes from both systems eventually spiral toward each other, either coalescing into a single massive object or ejecting one from the system completely. The Infinity Galaxy completely breaks this pattern. The supermassive black hole occupies a position directly between the two galactic nuclei, suspended in a vast expanse of glowing hydrogen gas stripped from both galaxies during their collision. This positioning should be gravitationally untenable. The black hole should be attracted toward one nucleus or the other, not floating between them like a cosmic mediator supervising the galactic impact. Peter van Dokkum and Gabriel Brammer, the astronomers who identified this system, believe they're observing something called direct collapse black hole formation. Rather than forming from stellar death, this black hole might have originated directly from the gravitational collapse of a massive gas cloud created during the galaxy collision. The mechanism functions as follows. When the two galaxies crashed together, they generated enormous gas streams flowing between their cores. Under precisely correct conditions, these gas streams can become so massive and dense that they collapse directly into a black hole without ever forming stars. It's like witnessing a cosmic avalanche so powerful it creates its own gravitational prison. This direct collapse mechanism could explain one of Webb's most perplexing discoveries in the early universe. The telescope has identified supermassive black holes that are far too massive relative to their age, reaching enormous proportions faster than traditional formation models permit. If black holes can form directly from collapsing gas clouds, they could achieve supermassive status much more rapidly than previously considered possible. The Infinity Galaxy represents a real-time laboratory for studying this exotic formation process. The black hole appears to be actively consuming gas flowing between the two galactic cores, expanding as the collision progresses. Radio observations reveal intense energy emissions from precisely where the black hole should be positioned, confirming it's actively accreting matter. The most disturbing aspect of the Infinity Galaxy collision isn't what we can observe happening currently, is what this discovery implies about the violent processes that sculpted the early universe. If direct collapse black hole formation was prevalent during the cosmos's youth, the universe experienced a phase of incredible violence and chaos we're only beginning to comprehend. And that violence left behind structures even stranger than wandering singularities, orphaned worlds broadcasting mysteries. Hundreds of orphaned planets are drifting through space in binary configurations, and they're transmitting radio signals that defy explanation. James Webb has catalogued over 500 free-floating planets in the Orion Nebula that orbit no star. These cosmic wanderers, each roughly Jupiter's size, have been expelled from their original planetary systems and now drift through the frigid emptiness of interstellar space. What renders them genuinely bizarre is that many travel in pairs, orbiting each other at separations ranging from 25 to 400 times the Earth-Sun distance. Scientists designate these paired wanderers Jupiter mass binary objects, or jumbios. They challenge every planetary formation theory we've developed. Planets typically form in the disks of gas and dust encircling young stars, slowly accumulating material until reaching their final dimensions. The gravitational choreography required to create binary planets should be extraordinarily rare, yet Webb has discovered dozens of these cosmic pairs. The mystery intensified when astronomers directed radio telescopes at these paired planets and detected something unprecedented. Several jumbios are emitting radio signals with characteristics never observed from planets previously. These aren't the typical emissions you'd expect from worlds with magnetic fields interacting with charged particles. They're producing gigahertz frequency radio bursts, thousands of times higher frequency than FM radio signals. On Earth, radio signals at these frequencies originate from technological sources or extremely energetic astronomical phenomena like pulsars and quasars. Discovering them emanating from rogue planets suggests these worlds are experiencing physical processes that don't exist anywhere else in our solar system. The radio emissions appear linked to the binary nature of these planets. When two massive objects orbit each other, they create complexes, gravitational interactions that can generate powerful magnetic fields and electrical currents. Consider it cosmic friction on a scale we've never encountered previously. The jumbos are essentially giant electrical generators powered by their orbital dance, yet the signals themselves remain deeply puzzling. Different pairs of jumbos produce different radio signatures, suggesting each binary system possesses its own unique electromagnetic personality. Some emit steady streams of radio waves, while others produce sporadic bursts following no apparent pattern. The implications are unsettling. If these orphaned worlds can generate radio signals this powerful, what else might they be capable of? Their magnetic fields could be orders of magnitude stronger than anything we observe in our solar system, creating space weather phenomena that could affect nearby stellar systems. Even more disturbing is what the existence of so many jumbos suggests about planetary system formation. If hundreds of these paired worlds exist in just one nebula, there could be millions or billions scattered throughout our galaxy. Each represents a failed solar system, a cosmic tragedy where gravitational interactions went catastrophically wrong and ejected planets into eternal night. These rogue worlds are cosmic orphans, forever separated from the warmth and energy of stellar companionship. They exist in perpetual darkness, their only heat source coming from slow, radioactive decay in their cores and tidal forces generated by their orbital dance with their companion. But as disturbing as these wandering planets are, Webb discovered worlds that challenge our understanding of planetary formation in even more fundamental ways. The next discovery would force scientists to reconsider everything they thought they knew about how planets form around young stars. The waterless world factory. A young stellar system is violating the fundamental rules of planet formation by creating worlds composed of the wrong materials. In the star-forming region designated NGC 60 through 55, James Webb discovered a planet-forming disk that contains almost no water but is enriched with carbon dioxide exactly where Earth-like planets should be forming. This finding demolishes one of the most fundamental assumptions about how rocky planets develop around young stars. Every planetary formation model assumes the regions around young stars where rocky planets form should be dominated by water ice and silicate minerals. Water ranks among the most abundant molecules in the universe, and its presence in planetary disks is considered essential for creating the types of worlds that could potentially harbour life. The disk surrounding the star Zu-10 throws all these assumptions into chaos. When Webb examined this system using its near-infrared spectrograph, astronomers expected to observe the familiar signature of water vapour mixed with other common compounds. Instead, they found a disk where carbon dioxide dominates the inner regions where terrestrial planets typically form. Water is so scarce it's barely detectable, creating an environment unlike anything scientists have modelled previously. This discovery challenges everything we comprehend about planetary formation chemistry. On Earth, water played a crucial role in creating our planet's geology, atmosphere, and ultimately the conditions that permitted life to emerge. A planet forming in the Zu-10 system would develop under completely different chemical conditions, potentially creating types of worlds that have no analogue in our solar system. Two competing theories attempt to explain this bizarre chemistry, and both have unsettling implications. The first suggests intense ultraviolet radiation from either the young star itself or from massive nearby stars has essentially sterilized the disk, fragmenting water molecules and driving hydrogen away while leaving oxygen to combine with carbon. The second theory is even more disturbing. The carbon dioxide dominance might result from unusual conditions in the dust grains comprising the planetary disk. Instead of being coated with water ice like dust grains in normal systems, these particles might be covered with carbon dioxide due to specific environmental conditions around this young star. Either explanation suggests planetary formation can follow pathways astronomers never imagined. If ultraviolet radiation can strip water from planet-forming disks, numerous potentially habitable worlds might never acquire the chemical building blocks they need to support life. The galaxy could be filled with arid carbon dioxide-rich planets that formed under conditions hostile to the chemistry we associate with biology. This discovery also raises questions about the diversity of planetary systems throughout the galaxy. If planet formation can produce such dramatically different chemical environments, there might be entire classes of worlds operating according to geological and atmospheric processes we've never encountered. The Xueten system represents a natural laboratory for studying alternative planetary formation pathways. As planets in this system continue developing, they'll provide insights into how worlds form when the basic chemical ingredients fundamentally differ from what we observe in our own solar system. But the strange chemistry of planet formation was just one of many atmospheric mysteries Webb would uncover. The telescope's next target would reveal a world so hostile and alien that it challenges our definition of what constitutes a planetary atmosphere, the impossible hell planet. A world so close to its star that its surface glows like molten metal somehow maintains an atmosphere that violates every law of planetary science. 55. Cancri E orbits its star so closely it completes a full orbital period in just 18 Earth hours. This infernal planet is tidally locked, meaning the same hemisphere always faces its star, creating a day side hot enough to liquefy copper and a night side plunged into eternal darkness. Surface temperatures reach over 4,000 degrees Fahrenheit, hot enough to vaporize most known materials. By every rule of planetary physics, this world should have lost its atmosphere billions of years ago. James Webb discovered something impossible. This hell planet not only possesses an atmosphere, but it's composed of materials that shouldn't be able to exist as gases at such extreme temperatures. The atmosphere appears enriched in carbon monoxide and carbon dioxide, creating a thick envelope around a world that should be as airless as Mercury. The discovery emerged through careful temperature measurements using Webb's mid-infrared instrument. When astronomers measured thermal emissions from the planet's day side, they found it was cooler than prediction suggested. Something was blocking and redistributing the star's heat, and that something could only be an atmosphere thick enough to transport energy from the scorching day side to the frozen night side. This atmospheric circulation creates one of the most extreme weather systems ever discovered. Imagine winds howling at thousands of miles per hour, carrying vaporized rock and metal from the day side to the night side, where these materials condense and precipitate as rain composed of molten minerals. The temperature differential between day and night sides should exceed 3,000 degrees, yet the atmosphere somehow moderates this difference through convection currents, operating under conditions no Earth-based laboratory could replicate. What renders this atmosphere truly impossible is its origin. The hell planet's atmosphere cannot be a remnant from its formation, because solar winds from its nearby star would have stripped away any primordial gases within millions of years. Instead, researchers believe this is a secondary atmosphere continuously bubbling up from the planet's interior. Visualize a world where the crust itself is boiling. The intense heat and tidal forces from the nearby star are literally cooking the planet's interior, causing carbon-rich materials deep underground to vaporize and escape through volcanic outgassing. The atmosphere is constantly being destroyed by stellar radiation and constantly being replenished by geological processes operating at temperatures that would vaporize most known materials. This creates an infernal cycle where the planet's own interior feeds its impossible atmosphere. Vaporized rock rises from the surface, gets transported around the planet by supersonic winds, condenses on the night side, and rains back down as liquid metal and stone. The entire world has become a massive distillation apparatus, operating under conditions that push the boundaries of physical possibility. The existence of 55 Cancri's atmosphere suggests planets can maintain gaseous envelopes under far more extreme conditions than scientists previously thought possible. This has profound implications for our understanding of potentially habitable worlds. If atmospheres can survive in such hellish environments, they might also persist around planets we've dismissed as too hostile for any kind of atmospheric chemistry. But the Hell planet's impossible atmosphere was merely preparation for Webb's next discovery. The telescope was about to encounter a visitor from another star system that would challenge our understanding of time itself, the ancient interstellar messenger. An ancient comet from another star system is racing through our solar system, and it's older than Earth, the Sun, and everything we call home. Comet 2I Borisov appears unremarkable initially. It's approximately 7 miles wide, composed of ice and rock, and follows a trajectory that will carry it past our Sun before returning to the void between stars. But James Webb's detailed analysis revealed something that shouldn't be possible. This interstellar visitor is approximately 7 billion years old, making it 3 billion years older than our entire solar system. When astronomers tracked the comet's steep trajectory through space, they realized it originated from the Milky Way's thick disk, a region of our galaxy populated with ancient stars that formed when the universe was much younger. This cosmic wanderer has been drifting through interstellar space since before the Sun was even a possibility in a stellar nursery. It predates Earth, Mars, Jupiter, and every planet in our neighbourhood. Webb's near-infrared spectrograph revealed the comet's coma, the cloud of gas and dust surrounding its nucleus, is dominated by carbon dioxide rather than the water vapour typical of comets from our solar system. This unusual composition provides clues about the chemical environment of the star system, where it formed billions of years ago. The comet is travelling at over 130,000 miles per hour, fast enough to cross the entire United States in less than 2 minutes. Its trajectory is unusually flat and direct, unlike anything else in our solar system. This interstellar intruder follows the gravitational rules of the galaxy rather than our Sun, treating our entire solar system as just another obstacle to navigate around. What renders this ancient visitor truly unsettling is what it represents. 2I Borisov is a messenger from a time when the universe was radically different from today. 7 billion years ago, the Milky Way was more chaotic and violent. Star formation rates were higher, heavy elements were scarcer, and the chemical processes that build planets operated under different conditions. This comet formed around a star that lived and died billions of years before our Sun existed. It survived its parent star's death, possibly a violent supernova explosion that destroyed its original solar system and sent it wandering through the galaxy. For 3 billion years it travelled through the cosmic deep, a frozen time capsule carrying chemical signatures from an ancient epoch. The fact we're observing it now raises disturbing questions about how many other ancient visitors might be passing through our solar system undetected. 2I Borisov is only the second confirmed interstellar object ever discovered, but statistical models suggest dozens or hundreds of these cosmic time travellers should be crossing our neighbourhood at any given moment. Each represents a fragment of a destroyed world, a piece of cosmic history that survived catastrophes we can barely imagine. They're archaeological artifacts from stellar systems that existed when the universe was young, carrying information about galactic conditions from epochs no other objects can provide. But 2I Borisov also serves as a reminder of our solar system's ultimate fate. In several billion years, when our Sun begins dying, objects from our world might be ejected into interstellar space, becoming ancient wanderers that will puzzle astronomers in distant galaxies long after Earth is gone. The ancient comet's visit was a preview of cosmic timescales that dwarf human comprehension. But Webb's surveys revealed objects even more mysterious than ancient visitors from dead star systems, the little red enigmas. 300 mysterious objects are glowing in the early universe, and astronomers cannot determine what they are. James Webb's deep surveys have uncovered a new population of cosmic structures that don't fit into any known category. These little red dots appear as tiny crimson pinpricks of light scattered throughout images of the early universe. Their properties are so unusual that scientists are struggling to classify them. Each one is far brighter than it should be given what we know about galaxy and star formation in the universe's youth. The mystery begins with their colour. In astronomy, Reddened light usually indicates either great distance or cool temperatures. These objects are definitely distant, existing when the universe was less than 1 billion years old. But they're also incredibly luminous, producing enormous amounts of energy through unknown processes, creating a combination of properties that doesn't match any object in the modern universe. Using advanced techniques like infrared imaging and spectral energy distribution analysis, astronomers at the University of Missouri identified 300 of these enigmatic objects in Webb's data. Each one appears roughly the size of early galaxies, but produces far more light than galaxy formation models predict. If they're galaxies, they're unlike any that exist today. The objects are so bright they force scientists to reconsider how galaxies could have formed in the early universe. Traditional models assume the first galaxies grew slowly, accumulating matter through gravitational collapse over hundreds of millions of years. The little red dots suggest some process was creating massive luminous structures much more rapidly than current theories allow. But here's where the mystery deepens. When astronomers attempt to determine exactly what's producing all this light, the answers don't make sense. Some objects appear point-like, suggesting they might be powered by supermassive black holes rather than distributed star formation. Others show evidence of extended structure, indicating they might be genuine galaxies undergoing extraordinarily rapid star formation. The most disturbing possibility is that these objects represent a completely unknown phase of cosmic evolution. During the universe's first billion years, physical conditions were drastically different from today. Matter was denser, dark matter interactions were more frequent, and the cosmic web of large-scale structure was still forming. Perhaps these conditions allowed for types of object formation that cannot happen in the modern universe. Some little red dots show evidence of extremely high-energy processes. They emit X-rays, ultraviolet radiation, and infrared light in patterns suggesting violent, chaotic energy production. Whatever is powering these objects is operating under extreme conditions that push the boundaries of known physics. The objects also appear distributed randomly throughout space, rather than clustered in regions where early galaxy formation was expected to occur. This random distribution suggests they might represent a fundamental property of the early universe, rather than rare, isolated phenomena. Bingjie Wang, the graduate student leading the research, emphasizes that even if only a few of these objects are confirmed to exist in the early universe, they will force scientists to modify existing theories of galaxy formation. The sheer number of mysterious objects Webb has found suggests our understanding of cosmic evolution during the universe's youth is fundamentally incomplete. The little red dots represent perhaps the most significant challenge to cosmology that Webb has discovered, but their mystery pales in comparison to what the telescope found when it looked at the large-scale structure of the universe itself. The cosmic rotation mystery galaxies across vast regions of space are spinning in synchronized patterns that suggest the universe might have been born rotating. In what may be James Webb's most mind-bending discovery, astronomers have found evidence that galaxies separated by millions of light-years are rotating in coordinated patterns. This cosmic choreography defies our understanding of how structure forms in the universe and raises the possibility that the entire cosmos was born with a preferred direction of rotation. The discovery emerged from observations of 263 galaxies captured during Webb's Advanced Deep Extragalactic Survey. When astronomers analysed the orientation and rotation patterns of these distant star systems, they found something that should be impossible according to standard cosmological models. Galaxies that are far too distant to have any gravitational influence on each other are spinning in similar directions. Think of discovering that every wind turbine across an entire continent is rotating in exactly the same direction, even though there's no wind pattern that could coordinate their motion. The galaxies are separated by distances so vast that light from one would take millions of years to reach another. Yet they're all participating in the same cosmic dance. Lior Shamir, the computer scientist who led the analysis, identified two possible explanations for this phenomenon, and both are deeply unsettling. The first is that the universe was born rotating. If the Big Bang itself had angular momentum, it could have imprinted a preferred rotational direction on the cosmic structure that formed afterward. This explanation aligns with black hole cosmology, a theory suggesting our entire observable universe might be the interior of a massive black hole within a larger parent universe. If true, the rotational patterns Webb observed could be evidence of the parent black hole's spin transmitted across cosmic scales through mechanisms we don't understand. The second explanation is even more disturbing for conventional cosmology. If the universe wasn't born rotating, then the coordinated galaxy spins suggest existing theories about cosmic evolution are fundamentally incomplete. Some unknown force or field must be operating on scales larger than anything scientists have previously considered. The implications extend far beyond galaxy formation. A rotating universe would have different physical properties than the static cosmos described by standard models. Space and time themselves might have preferred directions, creating asymmetries in physical laws that could affect everything from particle physics to the ultimate fate of the universe. The discovery also raises questions about dark energy, the mysterious force driving cosmic expansion. If the universe has a preferred rotational axis, dark energy's effects might vary depending on direction, creating a cosmos that expands faster in some directions than others. This could explain some of the anomalies Webb has found in cosmic expansion rates. Perhaps most unsettling is what a rotating universe suggests about our place in the cosmic hierarchy. If our universe is spinning inside a larger structure, it implies reality extends far beyond the observable cosmos. We might be living inside just one component of an incomprehensibly vast multiverse where entire universes rotate like galaxies within some higher dimensional space. The coordinated galaxy rotations represent a fundamental challenge to our understanding of cosmic structure formation and the nature of space itself. But the universe's hidden rotations were just the beginning of Webb's assault on conventional physics. The impossible feeder. A black hole in the early universe is devouring matter 40 times faster than the laws of physics allow, and it's growing at impossible rates. Hidden among thousands of X-ray sources in deep space, James Webb identified a supermassive black hole that's breaking fundamental rules about how quickly these cosmic monsters can feed. The object designated ELID 568 is consuming matter at 40 times its theoretical limit, a rate so extreme it challenges our understanding of black hole physics. Every black hole has what scientists call an Eddington limit, the maximum rate at which it can accrete matter without the intense radiation pressure from superheated gases blowing away its food supply. Think of trying to drink from a fire hose. Beyond a certain flow rate, the pressure becomes so intense it prevents further consumption. ELID 568 is somehow drinking from 40 fire hoses simultaneously. The discovery required combining Webb's infrared sensitivity with data from NASA's Chandra X-ray Observatory. ELID 568 was initially buried among thousands of bright X-ray sources, invisible to optical telescopes but blazing in high-energy radiation. Webb's unique infrared capabilities allowed astronomers to identify the faint counterpart emissions that revealed the object's true nature. What renders this black hole's feeding frenzy truly disturbing is the implications for its growth rate. At such extreme accretion rates, ELID 568 could have gained most of its current mass in a single episode of rapid feeding. The black hole appears to be undergoing what astronomers call a super-Eddington accretion phase, consuming enormous amounts of matter in a relatively brief cosmic time span. The object exists just 1.5 billion years after the Big Bang, when the universe was still in its infancy. For a black hole to reach supermassive status so quickly, while respecting normal feeding limits, would require starting from impossibly large seed masses. ELID 568's extreme feeding rate provides a potential solution to this cosmic timing problem. The velocity and volume of material flowing away from the black hole suggests substantial portions of its mass growth occurred during similar feeding frenzies. These aren't gradual accretion processes spread over billions of years, but violent consumption events that can increase a black hole's mass by enormous factors in cosmic eye blinks. The physics of such extreme feeding remains poorly understood. The black hole is somehow stabilizing the accretion process despite radiation pressures that should blow away its food supply. Either the black hole has developed some mechanism for controlling radiation pressure, or the surrounding matter has properties allowing it to resist being blown away. LID 568 represents the extreme end of black hole feeding behavior, operating under conditions that push physics to its breaking point. The discovery suggests the early universe hosted feeding events far more violent and rapid than anything seen in the modern cosmos. These fast-feeding phantoms could explain how supermassive black holes reach their enormous sizes so quickly in cosmic history. Instead of slow, steady growth over billions of years, they underwent brief but intense feeding episodes that increased their masses by factors of 10 or more. But LID 568's impossible feeding rate was just one example of the bizarre behaviour Webb was finding throughout the early universe. The sleeping giants. Massive galaxies are sitting dead and silent in regions of space where they should be blazing with star formation, and astronomers cannot explain why they stopped growing. James Webb has discovered what researchers are calling quenched galaxies scattered throughout the early universe. Massive star systems that mysteriously shut down their star formation processes when they should have been in their most active phase. These cosmic giants contain billions of stars but show no signs of creating new ones, defying every model of how galaxies evolved during their youth. The discovery emerged when astronomers examined galaxies that formed between 600 million and 6 billion years after the Big Bang. During this period, the universe was rich with gas and dark matter, creating ideal conditions for rapid star formation. Most galaxies from this era should be blazing with the light of newly formed stars, consuming available gas at furious rates to build their stellar populations. Instead, Webb found numerous massive galaxies that appear to have fallen into cosmic hibernation. These systems contain stellar masses comparable to our Milky Way, but show none of the vigorous star formation expected from young galaxies. They're like massive cities where all construction suddenly halted for no apparent reason. The dormant state during what should have been their most active period is what makes them so puzzling. Like a flower that stopped blooming at the height of spring, these galaxies ceased growing at the peak of their development. But unlike nature's cycles, there's no obvious explanation for what caused their cosmic slumber. Several theories attempt to explain this bizarre behaviour, and each one challenges fundamental assumptions about galaxy evolution. The first suggests supermassive black holes at the centres of these galaxies became so active that their energy output heated surrounding gas to temperatures too hot for star formation. This process, called active galactic nucleus feedback, can shut down star formation across entire galaxies. But the timing doesn't match. The quenched galaxies show signs of having shut down their star formation before their central black holes became active enough to cause such widespread heating. Something else must have triggered their dormancy. A second theory proposes these galaxies consumed their gas supplies so rapidly during an initial burst of star formation that they literally ran out of fuel. This explanation requires star formation rates far higher than current models predict, suggesting early galaxies could build stars much more efficiently than modern systems. The most disturbing possibility is that the quenched galaxies encountered some unknown process that doesn't exist in the modern universe. The early cosmos operated under different physical conditions, with higher matter densities and different dark matter distributions. Perhaps these conditions allowed for star formation, shutdown mechanisms we've never observed. The existence of dormant galaxies in the early universe has profound implications for our understanding of cosmic evolution. If massive galaxies could shut down their growth processes so early in cosmic history, it suggests galaxy formation is far more complex and unpredictable than scientists previously believed. The metallic rain world, a rogue planet drifting through space, has developed the most bizarre atmosphere ever discovered, with separate cloud layers made of iron and magnesium minerals. VHS 1256b is unlike any world in our solar system. This cosmic wanderer doesn't orbit a star but instead drifts freely through the galaxy, illuminated only by the faint glow of its own internal heat. James Webb's detailed atmospheric analysis revealed something unprecedented. This rogue planet has a layered atmosphere where iron rain falls through clouds made of silicate minerals. The planet's atmosphere resembles a cosmic layer cake, with different types of metallic clouds stacked at various altitudes. Near the surface, a dense layer of iron clouds creates weather patterns unlike anything on Earth. These aren't wisps of water vapour, but thick concentrations of vaporized metal that condense and fall as liquid iron rain during the planet's storms. Higher in the atmosphere, a second cloud layer composed of silicate minerals creates an entirely different weather system. These mineral clouds form when temperatures and pressures reach exactly the right conditions for silicon compounds to vaporize and condense. The interaction between these two cloud layers creates atmospheric dynamics that push the boundaries of planetary science. Webb's infrared observations revealed both cloud layers are patchy and constantly changing, suggesting active weather patterns driven by the planet's rotation and internal heat sources. The iron clouds appear to follow different circulation patterns than the silicate clouds, creating a complex three-dimensional atmospheric structure that varies dramatically across the planet's surface. But the most mysterious aspect of this world's atmosphere comes from high above both cloud layers, where Webb detected what researchers call hotspots. These are regions of intense heat that appear to be powered by auroral processes, electromagnetic phenomena similar to Earth's, northern lights but operating at energy levels that would be lethal to any known form of life. The auroras suggest VHS 12U56b has an incredibly powerful magnetic field, far stronger than anything in our solar system. This magnetic field interacts with charged particles in interstellar space, creating electrical currents that heat portions of the upper atmosphere to temperatures exceeding those found in the metallic cloud layers below. The existence of such complex atmospheric chemistry on a rogue planet raises disturbing questions about planetary formation and evolution. VHS 1256b somehow developed and maintained this elaborate atmosphere while drifting through the cold emptiness of interstellar space, far from any stellar energy source. This suggests rogue planets might be capable of supporting much more complex atmospheric processes than scientists previously imagined. If one wandering world can develop iron rain and silicate clouds, there could be millions of similar objects throughout the galaxy, each hosting unique atmospheric phenomena we've never considered possible. The cosmic rotation mystery galaxies across vast regions of space are spinning in synchronized patterns that suggest the universe might have been born rotating. In what may be James Webb's most mind-bending discovery, astronomers have found evidence that galaxies separated by millions of light-years are rotating in coordinated patterns. This cosmic choreography defies our understanding of how structure forms in the universe and raises the possibility that the entire cosmos was born with a preferred direction of rotation. The discovery emerged from observations of 263 galaxies captured during Webb's Advanced Deep Extragalactic Survey. When astronomers analysed the orientation and rotation patterns of these distant star systems, they found something that should be impossible according to standard cosmological models. Galaxies that are far too distant to have any gravitational influence on each other are spinning in similar directions. Think of discovering that every wind turbine across an entire continent is rotating in exactly the same direction, even though there's no wind pattern that could coordinate their motion. The galaxies are separated by distances so vast that light from one would take millions of years to reach another. Yet they're all participating in the same cosmic dance. Lior Shamir, the computer scientist who led the analysis, identified two possible explanations for this phenomenon, and both are deeply unsettling. The first is that the universe was born rotating. If the Big Bang itself had angular momentum, it could have imprinted a preferred rotational direction on the cosmic structure that formed afterward. This explanation aligns with black hole cosmology, a theory suggesting our entire observable universe might be the interior of a massive black hole within a larger parent universe. If true, the rotational patterns Webb observed could be evidence of the parent black hole's spin transmitted across cosmic scales through mechanisms we don't understand. The second explanation is even more disturbing for conventional cosmology. If the universe wasn't born rotating, then the coordinated galaxy spins suggest existing theories about cosmic evolution are fundamentally incomplete. Some unknown force or field must be operating on scales larger than anything scientists have previously considered. The implications extend far beyond galaxy formation. A rotating universe would have different physical properties than the static cosmos described by standard models. Space and time themselves might have preferred directions, creating asymmetries in physical laws that could affect everything from particle physics to the ultimate fate of the universe. The discovery also raises questions about dark energy, the mysterious force driving cosmic expansion. If the universe has a preferred rotational axis, dark energy's effects might vary depending on direction, creating a cosmos that expands faster in some directions than others. This could explain some of the anomalies Webb has found in cosmic expansion rates. Perhaps most unsettling is what a rotating universe suggests about our place in the cosmic hierarchy. If our universe is spinning inside a larger structure, it implies reality extends far beyond the observable cosmos. We might be living inside just one component of an incomprehensibly vast multiverse where entire universes rotate like galaxies within some higher dimensional space. The coordinated galaxy rotations represent a fundamental challenge to our understanding of cosmic structure formation and the nature of space itself. But the universe's hidden rotations were just the beginning of Webb's assault on conventional physics, young stars making old elements. young stars are creating heavy elements that shouldn't exist yet, forging cosmic chemistry that defies our understanding of stellar evolution. James Webb has discovered young star systems producing heavy elements like oxygen, carbon, and nitrogen at levels that should be impossible given their age. These stellar nurseries are creating complex chemistry that, according to every model of stellar evolution, requires billions of years to develop through successive generations of star formation and death. The mystery centers on metallicity, the astronomical term for elements heavier than hydrogen and helium. In the early universe, only these two lightest elements existed in significant quantities. All heavier elements, from carbon and oxygen to iron and gold, had to be forged in the nuclear furnaces of massive stars and dispersed through space when those stars exploded as supernovae. This process should take time. The first generation of stars, called Population III stars, would have been made almost entirely of hydrogen and helium. When they died, they enriched the surrounding space with newly created heavy elements, allowing the second generation of stars to form with slightly more complex chemistry. This cosmic recycling process continues over billions of years, gradually increasing the metallicity of star-forming regions. Webb has found star systems that appear to have skipped several steps in this process. Young galaxies that formed when the universe was less than 1 billion years old show metallicity levels that should require multiple generations of stellar evolution. They're producing oxygen, carbon, and nitrogen at rates that don't match their apparent age. The most extreme example comes from the galaxy GS-Z12-0, observed just 350 million years after the Big Bang. Spectroscopic analysis revealed bright emission lines and evidence of heavy element production that suggests the galaxy has already undergone significant stellar evolution despite existing during cosmic infancy. This impossible chemistry forces scientists to reconsider fundamental assumptions about early star formation. Either the first generation of stars was far more massive and short-lived than current models predict, allowing them to create and disperse heavy elements much more rapidly, or some entirely unknown process was enriching the early universe with complex chemistry. The first possibility suggests population III stars were cosmic monsters, perhaps hundreds of times more massive than our Sun. These stellar giants would have burned through their nuclear fuel in just a few million years, before exploding in hypernovae that scattered heavy elements across vast regions of space. Such massive stars don't exist in the modern universe, but the extreme conditions of the early cosmos might have allowed their formation. The second possibility is even more disturbing. If unknown processes were creating heavy elements in the early universe, it means our understanding of cosmic chemical evolution is fundamentally incomplete. Some mechanism beyond stellar nucleosynthesis might have been operating during the universe's youth, creating complex chemistry through pathways we've never identified. The vanishing planet mystery. A world orbiting our nearest stellar neighbour keeps appearing and disappearing in Webb's observations, and astronomers cannot figure out why it exists at all. In what researchers are calling one of James Webb's most perplexing findings, the telescope detected a giant planet orbiting Proxima Centauri, our closest stellar neighbour, only to lose track of it completely during follow-up observations. This cosmic vanishing act has created one of the most baffling mysteries in exoplanet science. The planet tentatively appeared in Webb's initial observations as a thermal signature consistent with a world roughly Neptune's size, orbiting within the habitable zone of Proxima Centauri. The discovery would have been groundbreaking on its own, representing the closest potentially habitable planet to Earth ever found. But when astronomers attempted to confirm the detection with additional observations, the planet simply wasn't there. Subsequent imaging sessions showed no trace of the thermal signature that had been so clear in the original data. The planet had either moved to a position where Webb couldn't detect it, or it had somehow ceased to exist entirely. Several explanations have been proposed for this cosmic disappearing act, and each one challenges conventional understanding of planetary systems. The first suggests the planet has an extremely elliptical orbit that carries it far from its star for most of its year, making it detectable only during brief periods when it passes close enough to emit significant thermal radiation. But orbital mechanics makes this explanation problematic. A planet with such an extreme orbit around Proxima Centauri would be gravitationally unstable, likely affected by interactions with the star's known planetary companions. The gravitational dance in multi-planet systems creates complex dynamics that make highly elliptical orbits difficult to maintain. The second explanation is even more unsettling. The planet might be real but surrounded by a variable dust cloud or debris ring that periodically obscures it from Webb's infrared sensors. This would suggest the Proxima Centauri system is far more dynamically active than previously believed, with ongoing collisions or disruptions creating temporary veils around orbiting worlds. A third possibility challenges our understanding of planetary formation entirely. The thermal signature might represent a world that's still forming, accreting material from a protoplanetary disk in episodes that make it alternatively visible and invisible to infrared observation. This would mean planet formation is still actively occurring in the Proxima Centauri system, despite the star being billions of years old. The most disturbing explanation is that Webb detected something that isn't a planet at all. The thermal signature might represent a previously unknown type of cosmic phenomenon, perhaps a dense cloud of warm debris or even a failed star formation event occurring in the outer regions of the Proxima Centauri system. The brain-like universe. Ancient magnetic fields discovered throughout the cosmic web are as complex as human brain networks, and they're older than any known structure in the universe. James Webb has detected evidence of magnetic fields stretching across the largest structures in the cosmos, creating patterns of connectivity that eerily resemble the neural networks found in human brains. These primordial magnetic fields appear to be remnants from the universe's first billion years, when cosmic structure was still forming through processes we barely understand. The discovery emerged from Webb's observations of the cosmic web, the vast network of filaments and voids that organizes matter on the largest scales. Between galaxies and galaxy clusters, thin streams of gas and dark matter create bridges spanning hundreds of millions of light-years. Webb found these cosmic filaments are threaded with magnetic fields of extraordinary complexity. The magnetic field patterns show a level of organization that shouldn't exist in the early universe. Instead of simple uniform fields, Webb detected intricate networks with nodes, connections, and hierarchical structures that mirror the topology of biological neural networks. The similarity is so striking that researchers are using the same mathematical tools developed to study brain connectivity to analyze cosmic magnetism. These ancient magnetic fields raise fundamental questions about cosmic evolution. Standard models assume magnetic fields in space develop gradually as galaxies and stars form, with stellar winds and supernova explosions creating and amplifying magnetic structures over billions of years. The primordial fields Webb discovered appear to predate this process entirely. The fields show evidence of having influenced early galaxy formation in ways current theories don't account for. Magnetic pressure and magnetic reconnection events might have shaped how gas collapsed into the first stars, affecting stellar masses, formation rates, and the chemical evolution of early galaxies. Perhaps most disturbing is what these magnetic networks suggest about the nature of cosmic structure formation. The brain-like patterns indicate the universe developed organizational complexity far earlier than scientists believed possible. Instead of simple gravitational collapse creating cosmic structure, the early cosmos might have operated more like a vast information processing system. The heartbeat of darkness. A supermassive black hole at the center of our galaxy is pulsing with irregular rhythms that suggest unknown physics operating at the edge of space-time. Sagittarius A, the 4 million solar mass black hole at the Milky Way's center, has been quietly surprising astronomers for decades. But James Webb's continuous monitoring revealed something unprecedented. The cosmic monster exhibits erratic brightness fluctuations that resemble a heartbeat with no discernible pattern. Using Webb's near-infrared camera, researchers observed Sagittarius A for extended periods spread across multiple sessions. What they discovered was a black hole in constant flux, with its accretion disk producing a continuous but chaotic series of brightness changes punctuated by sudden dramatic flares. The observations showed constantly changing bubbling brightness across the black hole's event horizon region. Then, without warning, massive bursts of radiation would suddenly erupt from the accretion disk before calming down again. These flares appear completely random, defying every attempt to find underlying patterns or periodicities. Two mechanisms appear to be creating this cosmic heartbeat. Short-term fluctuations likely result from turbulence within the accretion disk, where magnetic field interactions compress plasma and create temporary flashes of radiation. Think of it as cosmic lightning occurring in the superheated gas, spiraling toward the black hole's event horizon. But the larger flares suggest something more dramatic. These massive brightness increases might result from entire chunks of matter crossing the black hole's photon sphere, the region where light itself begins to orbit the black hole before either escaping or falling past the event horizon forever. The irregular nature of these events indicates Sagittarius A is more active than astronomers previously realized. Instead of the relatively quiet, slowly feeding monster described in textbooks, the Milky Way's central black hole appears to be in a constant state of low-level violence, consuming matter in unpredictable episodes. What renders this behavior truly disturbing is its implications for black hole physics near the event horizon. The brightness fluctuations originate from regions where space and time are severely distorted by gravity, creating conditions where matter and energy behave according to principles that push general relativity to its limits. Dark matter violence. Invisible forces are reshaping cosmic structure through violent processes that leave galaxies shredded and scattered across millions of light-years. James Webb has uncovered evidence that dark matter, the mysterious substance comprising 85% of all matter in the universe, participates in violent interactions that can tear apart entire galaxies and reshape cosmic structure on the larger scales. These dark matter catastrophes operate through mechanisms that remain completely invisible except for their devastating effects on normal matter. The evidence comes from Webb's observations of galaxy clusters, regions where hundreds of galaxies are held together by the gravitational influence of massive dark matter concentrations. When these cosmic cities collide, they create some of the most energetic events in the universe, releasing energies comparable to billions of supernova explosions. But Webb's detailed imaging revealed the violence extends far, beyond the visible collision zones. Galaxies located millions of light-years from cluster collisions show signs of having been violently disrupted by gravitational forces that can only be explained by dark matter interactions, operating on previously unimaginable scales. The telescope detected extensive streams of stars and gas connecting galaxies across vast distances, creating bridge-like structures that span the space between separate galactic systems. These stellar streams represent the torn remnants of galaxies that have been gravitationally shredded by dark matter forces during cluster interactions. What makes this cosmic violence particularly disturbing is its hidden nature. While normal matter interactions create visible fireworks through electromagnetic radiation, dark matter collisions produce no light, no heat, and no electromagnetic signatures. The only evidence of these catastrophic events comes from their gravitational effects on the matter we can see. Webb's infrared sensitivity has revealed the full extent of this dark violence. Faint stellar streams and tidal tails extend for millions of light-years around galaxy clusters, creating vast spiderwebs of disrupted matter that previous telescopes were too insensitive to detect. Each stream represents a galaxy that has been partially or completely destroyed by dark matter interactions. Conclusion: living in the impossible. The universe. James Webb has revealed isn't the orderly, predictable cosmos we thought we inhabited. It's a realm of impossible objects, violent physics, and phenomena that operate beyond our comprehension. We've discovered galaxies that form too quickly, black holes that exist too early, and planets that maintain atmospheres under impossible conditions. The evidence suggests we might be living inside a rotating black hole universe, forever separated from whatever larger reality contains us. Dark matter is more violent than we imagined. Primordial magnetic fields show brain-like complexity, and throughout it all, the fundamental fabric of space-time might be more fragile than we ever suspected. These aren't just academic discoveries. They fundamentally alter what it means to be human in a cosmos that refuses to follow our rules. Every assumption about our cosmic environment has been challenged. We thought we understood galaxy formation, black hole, growth, and universal expansion. Instead, we've found a universe operating according to physics we don't comprehend. Perhaps most unsettling is the realization of how little we actually know. Despite centuries of astronomical progress, Webb's observations have uncovered phenomena requiring us to completely rewrite our understanding of cosmic evolution. If we've been this wrong about fundamental processes, what else have we missed? But Webb's revelations also offer profound wonder. The universe's capacity for surprise and complexity suggests cosmic evolution might be far richer than our models predict. If reality can produce impossible galaxies and naked black holes, it might also create forms of life and intelligence operating according to principles we haven't discovered. We're cosmic infants living in a universe that delights in violating our expectations. Every strange object Webb discovers represents an opportunity to expand our understanding of what's possible. The universe doesn't owe us comprehensibility. It operates according to its own logic, following principles that might be fundamentally alien to human intuition. The cosmos James Webb has revealed is strange, violent, and often incomprehensible, but it's also the only reality we have, and understanding it, no matter how disturbing that understanding might be, represents our best hope for navigating the cosmic future that awaits humanity among the stars.